The next thing we should talk about is major considerations when going out looking for data and before you actually go to download it. The first one is the integrity of the data. You should always examine the integrity of your data because there are several places online which will allow you to download GIS data. The first thing that you should check for is to make sure after you download it, if it is a complete download. Oftentimes, students will spend an entire week downloading their GIS data to find that when they are in step 12 of their analysis process and GIS crashes, that their data is corrupt because only half of it actually downloaded. The next question you should ask: was the data acquired from a legitimate source? So of course BitTorrent would likely be a place where you would not want to download GIS data. Recall that you'll need to cite the source of your data, and you will also be somewhat responsible for the results of the analysis and how it may impact design. The next question you should ask is: how old is the data? Sometimes the data may be too old, meaning that it may actually be obsolete, which leads us to the next question: does the data accurately represent the conditions on the site? So if the data is too old or too many changes occur to the site within a small period of time, you may find that your data to be obsolete, meaning that you simply cannot use it. The next major consideration is resolution. It is important to utilize the help and understand the terminology used to describe data resolution. So for example, if you're downloading terrain data, which is often the first piece of data that many analyzers will go out to download, especially when wanting to deal with elevation type information. Sometimes you may go out to the http://seamless.usgs.gov website to download elevation data. You may hear the terminology 1 arc second, 1/3 arc second, and 1/9 arc second. And what that basically means is the dimensions of each grid cell of the raster. So a 1 arc second means 30 meters. A 1/3 arc second means 10 meters. And a 1/9 arc second means about 3 meters, which is pretty close to LiDAR data resolution. So if you're looking for something that is high resolution, you're probably going to choose the 3 meter. If you want something that's low resolution, you're probably going to choose the 30 meter. So being able to understand what all of those terminologies mean is going to be important before you actually go to download the data. And oftentimes GIS data is very, very large, so you don't want to spend a lot of time wasted downloading the incorrect data resolution. So resolution kind of works like monitor screens, and of course the better the resolution, the more information that you're going to be able to see in your map. And of course the much larger the map is going to become because there's a lot more data there. In lower resolution maps you're not going to be able to see as much, but there's going to be a lot less data there, meaning that the data set file size is going to be much more smaller. When selecting which resolution size to download, you should take under consideration the type of analysis that you plan to run. Sometimes the type of analysis that you plan to run may not need a very high resolution data set. So there's no point in wasting computer resources and time processing high resolution data resources when it's not needed for your particular type of analysis. The next major consideration is the format of your data. Data can come in a wide variety of formats. So for example, if we think about elevation data can come in a wide range of formats, such as first return, bare earth. So again, it's going to be important to read the help information to understand exactly which format you plan to download. And again, many of these data sets are very large. They can range from 500 megabytes to a couple gigabytes in size. So you don't want to spend a lot of time downloading the incorrect data set. So make sure that you read the help menu and you're understanding exactly which format you're receiving the data in. And sometimes you may not exactly know, so you may have to download everything and just simply experiment. Once the data is downloaded, you want to make sure that you're going to be able to unpack the data. So oftentimes sites will not give you the data in an uncompressed form because it'll be pretty much 3 to 4 times the size of the original data set. So what they'll do is they'll compress it, they'll zip it up, and they'll host it out there, and then you'll have to download the compressed version. So one important consideration is to make sure that you have the tool that is needed to unpack your compressed files. So make sure that, I highly recommend anyway, to use 7Z. It's free, it doesn't cost any money, it will run on Windows 32 and 64-bit. To go out there and download this, you can get it from www.7-zip.org. The great thing about this tool is I find that it is capable of handling uncompressing very large data sets compared to the Windows built-in utility, and it also has excellent error detection, meaning that if your data set is incomplete for whatever reason, you have a greater chance of discovering this much earlier in your process because it will give you a CRC check error letting you know that your data set is incomplete and it could not uncompress it. So you may find 7Z to be quite useful. So again, make sure that you pay attention to the integrity of your data, the resolution of your data, and the format of your data when going out to download data, and before you actually spend a huge amount of time downloading data.